Okay, so hi folks, I gave you this My Maths task to do. It's from the A-level section, mechanics and kinematics graphs, and it's a good way of revising all the sort of basic and not so basic things to do with kinematics. So it all looks fairly straightforward, but then when I was doing the first question here, I got it wrong. I made a silly error. Okay, we should know that the area under a velocity time graph is the distance travelled. So what I did, I just found the total area under this triangle here, but that really wasn't what the question was asking, so I'm going to explain how we do this kind of question. So we have the area under velocity time graph gives you distance, the area under an acceleration time graph gives you change in velocity. Okay. Anyway, here we go. So this one here is deceptively difficult now. The total distance travelled. Well, this particle starts with a positive velocity. The velocity then reduces to 0, and then the velocity becomes negative. So we can think about this particle if we draw like a motion diagram for it. There's our time axis there. So this particle, we don't know exactly where it is, but we do know that it's moving with a positive velocity, and then at some point it reverses and it has a negative velocity. Okay, this would be t equals 0. Now, at this point here, where the velocity is 0, we haven't got a function to look at, so we can't work it out using algebra. But we can use some reasoning here. Look, if we think about these two triangles as being similar triangles, we know they're similar because they've both got a right angle and they've both got this opposite angle here. Well, these two short sides, these back sides are in the ratio 2 to 6, and we can also reason therefore that this line to this side must also be in the ratio 2 to 6. So we have 2 to 6 and 2 to 6. Okay, so we know that this point here must be 6. So it changes direction when time equals 6. So what we've got to do is work out the area travelled, the distance travelled, which is given by the area under the graph from 0 to 6. Okay, that's the distance travelled from 0 seconds to 6 seconds, and then it's going to come back a little way along its line in the next 2 seconds from 6 to 8. And again, the area of this small triangle here, use a bit of blue there, this will give us that distance as it comes back on itself, area 2. For area 1, if we look at the triangle, the base is 6, the height is 6, so the area is just half 6 times 6, is 18 metres. And area 2, the base is 2, the height is 2, so the area is half 2 times 2, which is 2 metres. Okay. So we travel 18 metres forwards and we travel 2 metres backwards. So total distance travelled is 20 metres. Okay. Okay, now this next one here is also quite a tricky question. So I've worked through a little solution here for us just to help us see what's going on. So, well, it's a particle whose velocity is changing with time. Notice how its velocity starts negative and then it ends positive. Okay, so in terms of its motion diagram for this one, well, here's the origin. We don't know exactly where it is, but we know it's moving towards the origin in the first 10 seconds because the velocity is negative. Okay, so it's moving backwards towards the origin, assuming its displacement is positive. At 10 seconds its velocity becomes positive, so it must be stationary at that point, and then it starts moving away from the origin with a positive velocity. Okay, constant acceleration, which is the gradient of this line here. So we know that the velocity function, if we differentiate that, we get the rate of change of velocity, which is the gradient and also the acceleration. So let's start doing the question parts. Calculate the velocity after 18 seconds. Well, in the first 10 seconds it changes from minus 19 to 0. So that's a change of 19 meters per second divided by 10. Okay, so the acceleration we're talking about here, given by the gradient of this line, is positive 1.9 meters per second. Okay, we get that just by doing this vertical distance divided by the horizontal distance. Okay, which is positive acceleration. Now, in the next 8 seconds, from 10 to 8, it will go at 8, the velocity will change by 1.9 meters per second, so we therefore do 8 times 1.9 to find its velocity after 18 seconds, giving us 15.2 meters per second. Okay, so I'll put that one here, and also mark it on the axis here for a later question. Now we want the displacement of the particle down here from its initial position after 18 seconds. So as we said, it comes towards the origin and away from the origin. We have to work out what this distance is here and the distance is here, which will give us the total displacement from the origin, which will be that distance in there. Okay. So in the first 10 seconds, the distance will be given by A1. So A1 is the area of this triangle here, or this triangle here, but let's do this one. Half base times height, so it's half times 10 times 19, giving us 95 meters. Okay, so this distance from 0 to 10 is 95 meters. And then distance travelled with positive acceleration is a half base times height, so a half times 8 times 15.2, giving us 60.8. So for our motion diagram, it starts here, it travels 95 meters towards the origin and then 60.8 meters away. So total displacement here from its starting point, well, it was minus 95 when it changed direction, and then it came back towards this starting point, 60.8 meters. So total displacement is negative 34.2. Notice it's negative because its final position here, is to the left of its initial position there. Okay, so obviously its displacement is negative, it's moved back towards the origin. The total distance travelled is simply the sum of the areas here under the velocity time curve graph in this case. The sum is 155.8. Rounding those to the nearest meter, we get negative 34.2.